Everyone. So today we will be starting with the next part in this light chapter, which is called refraction. So the meaning of refraction is that when light is traveling from one medium to another, okay, that is from one object to another, you can say, or an object made from one material, in that light is traveling, and when it moves to another object which is made from another second type of material, then a phenomena is observed in which light bends, which is called as refraction. So what is refraction? So it is nothing but the bending of light, the bending of light when light travels from one medium to another. So we can understand by drawing some boundary. Okay, suppose this is a boundary. This is a boundary which separates two medium. Okay, this above this line there is medium 1. Okay, medium 1 means it can be, let us say, air. Okay, and this is your medium 2. Okay, it can be also any material, let us say glass or any other material. So what will happen? Suppose this is a ray of light. If it travels to this medium, okay, if this is your incident ray, okay, you call this as incident ray. So this incident ray is emitting and it is striking on the boundary of this surface. Okay, this is the boundary. This is the boundary of two surfaces, or you can say two materials. Okay, so what happens after this? The expected path of this ray of light is it will see this medium is now a, you can say, translucent material, or let us consider transparent, because glass is transparent. Let me write it here. This material is what? Transparent. Okay, so transparent material means light will pass through. So the expected path of ray is like this. It will go straight. But what happens in reality? In reality, this is not the case. What will happen? This will bend somewhat like this. It will go somewhat like this. So this is now you're called as refracted ray. This is called as refracted ray because why? Because here what happens? You can observe that bending has occurred. Bending of light. See this ray is now bending. It was coming like this, now it has taken a turn like this. There is a slight bend of light. So this bending of light is called as refraction. So this is nothing but your refraction. This means this is the second phenomena in which the light is striking on the surface or the boundary of the two materials, which boundary means a surface or a plane where actually your two mediums are getting separated. That place, at that point, the ray of light will be bending, that is the light will be bending, and that is why this bending of light is called as refraction. Okay, so how this refraction is getting occurred, let us see this. Okay, again I will draw this, how this refraction is taking place. Suppose this is your this below this is your medium 2. Okay, as I told you, it is glass, and this was your medium 1, which is let us say till now we were discussing it in air. The reflection was in only one medium. This is medium 1, air. Okay, now what I'm traveling not what I'm trying to explain you is that this is your ray of light. Let us zoom into this. Okay, let us zoom this, and what will happen? You can see that this a ray of light will be somewhat like this. I'm zooming into this. Okay, this is one end of this ray of light, and let us say this is your another. Okay, like this the light is traveling, right? This is now actually a beam of your light. You can more accurately point it as like that. So this is your boundary. Okay, this was your on the left side of this ray of light. This ray of light we have zoomed in. Okay, this we have zoomed in. So this end is like this and the other end is like this. So what is the meaning is that this end. Okay, this end, what happens now? Normal, if I draw, it is somewhat like this. Okay, 90 degree to this is somewhat like this. This is 90 degree to this, and 90 degree to this also. So this is your normal to which you will consider the ray of light. Okay, this is all 90 degree because these are two parallel lines, so 90 degree. Okay, now what we are observing, consider this A point. Okay, what happens? The concept is that first of all you must remember that light in different medium. Okay, light travels at different speed in different mediums. Okay, so this is your concept, that is light travels at a different speed in different mediums. So till now there was air, so what will happen, this and this at A point, what will happen, this will enter the glass medium first. Okay, and it will, what will happen, there's a concept of optically rarer medium and optically denser medium, which will be see subsequently in the next topic is that only. Okay, so we will be seeing that. So now you understand that at this A point, this part of ray of light, this part will encounter the glass medium first and it will slow down first. Okay, and what will happen, it will see a gradual decrease in speed at first. Okay, so what will happen, it will try to bend like this. Okay, it will travel more in, you can say it will encounter this this boundary condition first, and what will happen, it will first see a gradual decrease in speed, and the light of ray will be bending, that means that will see a gradual decrease in speed first. Okay, here the speed will be decreased. Okay, and what will happen, this point, if we consider the normal point, this this side of equivalent this side of the ray of light, that is the right hand side of this ray of light, what will happen, it is still traveling in air, this point is still in air. Okay, this at this instant this part of ray is still in air, so what will happen, now it will continue to travel straight, whereas this will slow down a bit because of this change in medium. Okay, and what will happen, the band, this will now change at this point B. Till that time B, this ray is what, somewhat here, right, this ray will be somewhat here, and now what happens, now this part of ray will see a gradual decreasing in speed in light. So what will happen, so due to this, the light travels at different speed, due to this different speed we will observe that this part of this end will this end will, what will happen, this end will come out first. Okay, this point will be at this point A, this ray of light will be reaching first, and after some time this at this B point, this part of ray of light will be reaching. So what will happen, at this point they both will experience a change in speed. So till this time, till this point, this had already reached here, but now it will getting to start bend. So what will happen, overall we will see a bending of light. So we can see that this is now like this, this has now become somewhat like this, this has now come like this, and this is not bending till now, but now it will so what will happen, it will come this like this, and it is like going like this. So okay, so what will be drawing, so actually what we draw to represent this, okay, to represent this we only use a single ray. What we use only a single ray. This is for just explanation purpose. When we are drawing ray diagrams in case of refraction, so what we'll be doing, this was your the plane separating your both the mediums. So this is your traveling ray of light, and after that some time it will get bent. After this point it will start to bend. This is your anticipated path of ray of light, but actually what will happen, this becomes your incident ray. Let me write it fully so that you know, this is the incident ray, but now this is not reflected, this is refracted. So this is the concept. So what will happen? It will travel from one medium and it will enter into the another medium, but it won't go straight, it will bend. Okay, now let us first consider the case of a denser and rarer medium, that is optically denser and optically rarer medium. But first you need to understand that this point is important. Light travels at different speed in different mediums. Okay, light travels at different speed in different medium. So let us now first see the case of optically rarer and denser medium. So this is not based on that density concept which we have already studied in earlier classes, but this is optically rare and optically denser medium. Okay, so we classify these two types of mediums. So the medium, so we can see that these are both comparable. Okay, we always put a tag on a medium based on some you can say relative to other medium. Okay, we cannot call that, hey, this is a denser medium. That is wrong. We can't call that this is an optically dense medium. We always call this thing, suppose this glass is an optically denser medium, not optically denser medium or optically rarer medium. Means that rarer or denser means what? It is a superlative, it is a comparative degree. Okay, so we are seeing the denser or rarer in case with respect to some other medium. Okay, suppose there are two medium, there is medium 1 and medium 2. Okay, now what happens? Suppose the speed of light in this medium is speed of light in this medium is let us say x. Okay, x meter per second, and in this the speed of light is 2x meter per second. So in which case the speed is more? The speed is more in this medium 2 case. Okay, so speed is more in this medium case, in which it is less. It is less in this case. So what will you tag as optically rarer medium? So this is your optically rarer when you compare to this medium, that is medium 2. This is optically sorry, wrote it reverse. So this is your, the speed is less. Okay, in whatever material, if the speed is less when you compare it to some other material, this has now become your denser medium. Okay, this is your denser medium, and this one is what? This is rarer. So always in an optically rarer medium, the speed will be more. The speed will be more. And in an optically denser medium, the speed of light will be what? Less. So you can say that more the denser material is, less the speed of light will be in that, and less denser, that is rarer the material is compared to that material, in that case the speed of light will be more. Okay, so when the speed of light is more, I told you in the last case we discussed how a ray bends. So the speed of light, if it is more, okay, if speed of light is more, if speed of light is high, it means what? The bending will be less. Okay, bending will be less. This is a relation you need to understand. That means speed of light is more in see, rarer medium. So rarer medium, what will happen? In rarer medium, the speed of light will be high. It will be higher when you compare to denser medium. So if I see a denser medium, in denser medium what will happen? Speed of light, if I see, in that case compared to this rarer medium, the speed of light will be less, and what? Bending will be more. So this is an important concept you need to understand, that bending is more in denser medium, right? This is your you can say one of the most important concept which will govern your reflection case. So speed of light increases in rarer medium, that is why bending is less. That means, or you can term this as, you can call this as what? This is your refraction only. That is, bending means refraction is more in denser medium. So we can write now confidently, we can write that, we must write that in an optically rarer medium, in optically rarer medium, speed of light is more, hence less bending. Okay, less bending or refraction. Understood? And vice versa, you can write it for optically denser medium. Okay, you can write this, that in optically denser medium, speed of light is less, hence more bending, so that you can now clearly see. Okay, so this is your conclusion, you know this. Now let us consider a case of some refraction. Okay, so this is your, let us draw it more center. Okay, these are the two cases. So here it is air and it is glass. Okay, now in this case I am taking glass and air is here. So these are the two cases. First case is this, second case is this. I am taking that in this case the ray of light is traveling in the air medium, that is, I will mark this as the medium 1. Okay, and this is your medium 2 here. This glass is, in this case, is medium 1 and medium 2. So medium 1 is what? Medium 1, in I will specifically use medium 1 as in which medium, in which the ray of light is initially traveling. Okay, and 2 will be in which it gets refracted, that is, it will get bent. That means, on and summarize, if I summarize this is means that in this case, in medium 1, it means I will consider medium 1 is light traveling from. Okay, this is important, these terminal, light traveling from, and in this light traveling to. Okay, so these two pointers are important, which I am considering as medium 1 and medium 2. So here what is happening? This is your incident ray, this one is your incident ray, and now how the reflection will occur? Same case, what will happen? Since I told you that this is air is what? Rarer medium. It is optically rarer medium. There is a table and there is a term called refractive index, which by which you will know it is rarer and denser medium. Now you consider this, that air is a rarer medium and glass is what? Denser when compared to air. I told you that these two, denser and rare, are comparative quantities. So with respect to air, glass is denser medium. So I told you what? In this case of what? In the case of air, it is rarer medium. So speed of light, here the speed of light is more, right? And now in this case, the speed of light will be what? Less. The moment it enters this, at this point, the speed of light will be less. Okay, so it will now bend, that is for sure. Now there are two directions. It can bend like this also, or it can bend like this. Okay, it can bend like this or it can bend away. Okay, so these two directions are denoted by, first of all, again we will consider normal. So this is your boundary condition. So also in this case we have a concept of normal, which is perpendicular to this this surface, okay, the boundary. So this is your normal. So what happens if I extend this normal further in the back direction? Since the light is entering from rarer to denser medium, the speed of light will go down. The speed of light will go down, so it won't go further away from the normal, rather it will bend. And what it will do, it will bend towards the normal. It will bend towards the normal like this. Okay, this was your normal. This was your normal. And how the light of ray has emerged? This is your refracted ray now. Okay, refracted ray. So what it has done? It has bent towards the normal. So we can this is clear, okay, what I wrote, traveling to, traveling from. So what we can see, that ray of light is bending towards the normal. Okay, and now I will consider this case. Suppose this is the incident ray. Now this is entering at an angle. Okay, always it is an entering at an angle. It is not overlapping the normal. Okay, how will it will happen? This is your again normal. Now you tell me, which is your rarer medium? This is now, this air is now rarer when you compare it to glass. This is your denser medium. So ray of light is traveling from denser medium. This is traveling from denser. It is coming from denser medium. So here the speed of light will be what? It will be less when you compare to the speed of light in this case. So the moment, what will happen? The speed of light was less initially. Now after this point, the speed will suddenly increase. The speed will suddenly increase. And what will happen? It will try to go away from the normal like this. Okay, the speed will increase. The speed is increase means it will deviate from this path. Now this is your incident ray. This is your incident ray and this is your refracted ray. Okay, this is your refracted ray and this was your 90-degree angle. See this. This is your 90-degree angle. Now it is now bending away from the normal. This is your normal. So we can easily say that when the ray of light is traveling from an optically rarer medium to a denser medium, what will happen? The speed of light will reduce. Since the speed of light will reduce, it won't deviate too much from its original incident path and it will get bent and it will stick near to the normal. But what happens in denser case, in denser to rarer case, is that after this striking this boundary condition, the speed of light will increase because it is entering a rarer medium. In rarer medium, the speed of light will be more. Okay, so in that case, you can easily see that this will bend away from normal. So better you can write these points, that what will happen when ray of light travels from optically rarer to denser medium, it will bend towards the normal. Okay, and correspondingly for vice versa case, you can write that when ray of light travels from optically, I can better write like this. Okay, so I can write that when ray of light travels from optically, if it travels from optically denser medium to rarer medium, then it will bend away from the normal, this case. So this is clear. Okay, so it will be sticking closer to the normal case. It will be closer to this incident ray when it is traveling from rarer to denser medium. Okay, so this is your refraction, right? Now there are certain cases which we observe in daily life. Suppose I say there is a container. Okay, there is a container kept like this, and we have some object here. Say suppose a coin. We are having a coin here. Okay, this coin is here, and this is now filled with water. Okay, this complete is now filled with water. Let us mark the water by this. Let us say that this is filled with water, and a coin is immersed in a container, and you are observing. Okay, you are observing from somewhat like this. Like this. This is your case, right? What is happening? You are this ray of light is now suppose coming like this. Okay, these two are the ray of light. This is this incident ray, the incident light coming from this. Okay, this is placed in a room which is well lit. Okay, so what will happen if you are trying to observe from somewhere up of this container? This coin is placed in the immersed in water in a container. Now what happens is, since now this is water and water is a denser medium. Okay, denser medium, it is medium 1, and here is what? It is air. It is a rarer medium when you compare it to water. So this is water. Okay, this is water, and water is a denser medium when compared to air. So according to this, if I draw the normal in both these cases, suppose this is the normal here. So what will happen? I just now told you. Now this will deviate away from the normal. This will deviate away from the normal. So it will come around like this. Let us say like this. Okay. And this is your refracted ray, this white colored. And similarly, if I see the normal here, right? This is your normal. And if I draw the refracted ray in this case, again, this is denser medium. Again, the medium 2 is, this is second medium, right? So second medium is here, which is rarer medium. Again, it will bend away from the normal. It will bend away from the normal like this. Okay. So what you will observe is that these rays of light, if you backtrace them, if you backtrace these light, what will you observe is that it will be somewhat upside of this. Okay, and this is not a correct diagram, but because I am doing it in rough, what will you observe is that this coin will be a shift. This is now your apparent shift. That means what will happen? This is the real position of coin, but suppose your eye is here, right? Your eye is placed here. So your eye, on your eye, these rays, because these rays are being refracted, these rays have been bent because of this difference in medium. So your eyes will see that these rays of light are coming from somewhere here, this point, which is above the real point of the coin. So this there is a position shift in this point. Okay, it is the coin will appear to be somewhat raised from the its original position, which is your apparent position. This is called as the apparent position of object. Okay, which is not the real position. This is the apparent position. Why? Because of refraction. Because of this bending of light, the original rays which were coming out from this coin, they will get bent and then they will reach your eye. But your eyes will always have a tendency to see in a straight line. Your eye doesn't know that, hey, that ray of light is bending or reflecting or what is happening. Straight away, light is coming to your eyes. You can backtrace those rays, and wherever they are meeting to your eye, there will be only the image will be formed. So actually what will happen? This coin will appear somewhat raised. So this is what you call as a daily life example of a refraction case. Somewhat also sometimes in what you immerse an object half in water and half you take it in air, then that object will be appear to be as bent. Suppose you take a transparent beaker, let us say. Okay, a transparent beaker you take, and in this beaker, what are you doing? You are placing water, and this is transparent, and you are immersing suppose a rod in this. So what will happen? It will appear bent from this surface. So that is because of also it will appear as it has bent. So this bending is observed. We observe it from side. This is because of refraction, that is because of bending of light. See, this is when you observe it at an angle. Also, if you can you are also seeing it like this, let us consider this case also, because sometimes this can be asked as a problem or as a question, so better to discuss these both, how these ray diagrams are being. So again there is a water placed in this container, and now your object is placed here. Okay, this is your object, right? This is your object, and the observer is just above this. Observer is just above this. What we can say, above, just above this, like this is your let us say this is your observer, which is observing this. Okay, now if I draw the ray diagrams, what will happen? If I am taking like this, see, like this, suppose this is your ray is coming like this, okay, from this object, this yellow colored ones, these are your rays which are coming out from this. This is your incident ray. Now this is your boundary condition, right? From this side there is your medium 2. Always I told you that light, when it is traveling 2, it is your medium 2, and from is light is traveling from here, so this is medium 1, which is water, and which is a, this is a denser medium again, and this is your air, which is your rarer medium. Obviously above this water level there is air. So what will happen again, if I draw this normal, again you need to draw this ray diagram clearly, that's all, that's what we have to do. So again what will happen, this will try to deviate away from the normal, so it will go somewhat like this. Okay, it will go somewhat like this, but if you back trace these rays, right, it will be coming like somewhat like this, somewhat like this it will be. Okay, somewhat there it will be coming. If I draw it in the straight direction, that is how they will be coming from. Let me draw this more accurately, because these are not reflected too much away from the, so normal away means like this. Okay, consider your eye is everywhere on this, above this, so you can better understand this. Now if I back trace these, right, it will be somewhat like this. Okay, somewhat like this. Here they will be meeting. So again there is what, a shift. This is a apparent shift again. Okay, apparent shift again, and this was your real position. So meaning is what, when you are trying to observe a object which is placed in some other material, and you are observing from some other medium, okay, the object is placed in some other medium and you are observing some in some other medium, there will always be apparent shift depending on this dense, whether the medium is denser or rarer. So that is the case. Just I need to show these ray diagrams, so sometimes it is asked, so you know this. Now there are certain laws of refraction also, right? Laws of refraction also, like laws of reflection, we have laws of refraction also. So first law is that the incident ray, okay, the refracted ray and the normal, again they will lie in same plane. Okay, these lie in same plane. Like I told you in that case, suppose this is your incident ray, this is your refracted ray, means this is your incident ray, this is your refracted ray. If you turn this in the side view, they will be seen like this, one over the other. This is the front view which I was drawing, that this is the incident ray and this is your refracted ray. It was bending like this. Okay, this is refracted ray, my finger is, this one is refracted ray, this is your incident ray. So this it is like this when I'm drawing in the on the paper. Suppose you turn this 90 degree, and if you move it from the side, these incident ray and refracted ray are exactly one above the other. It is not like this. It is not like this. Okay, it is like this. So this is the meaning that they are lying in the same plane. The second law is a special law, and it is also termed as Snell's law. It defines actually the refractive index. Okay, it defines the refractive index. So what does this mean? That it is a refractive index related to the refractive index. So this law states that the ratio of sine of angle of I with the sine of angle of R is equal to the refractive index of the material. Okay, this is what it tells. And the condition is that the light must be of same wavelength. Light must have constant or same wavelength. That means a single color light can it be. Okay, that means whenever there is incident ray and whenever there is refracted of a say single color we are having, then the sin I by sin R is nothing but refractive index. So now let me tell you, these are the two laws, and this is your second law, which is a bit important, which is actually the which will be used in many of the numericals also. So let us try to understand what is the angle of reflection, refraction, and what is the angle of incidence when we are talking in case of a refraction. So this is obviously, this is your medium 1 and this is your medium 2. Okay, I am telling that this is a rarer medium, this is your denser medium. Obviously, when incident ray will be at an angle, okay, this is your incident ray. So obviously this angle between the normal and same as in that case of reflection, this angle is what? I. So this angle I is what? Angle of incidence. And as I told you that since this is a denser medium, it will be bending. This ray of light will be bending after striking the surface, and it will bend towards the normal. It will be more of the part of this ray will be towards the normal. So this is your refracted ray, right? So refracted ray, what will happen? The angle between this refracted ray and the normal is called as angle of refraction. So this is the meaning. So sine I upon sine R is what we call as the N. And N is what? N is called as the refractive index. N is called as the refractive index. Okay. Refractive index of what? Refractive index of material 2 with respect to material 1. Because this refractive index is a index which is used to distinguish materials whether they are optically rarer or optically denser. So that judgment is always based on the numerical value of this N, which is called as the refractive index. The more this value is, that means more the refraction is. Okay, more this value, that means more the refraction. That means refractive index, it is denoting the amount of refraction the ray of light will be going in that material. So if refractive index is more, it means refraction is more, that means bending is more. If refractive index is less, it means bending is less, that means refraction is less. Or you can call, when comparing two materials, you can call this as that refractive index is low, it means it is a rarer material. If refractive index is more, it is a denser material. Okay, so if I am considering this as rarer material, let us say air, and let us say this is now your glass. So these two are, air is having a refractive index value equal to 1, N is equals to 1, and glass is having a refractive index, let us say around 1.5. So this value is more. Okay, so that is why this is a denser medium and air it is a rarer medium. And always please understand that refractive index we calculate because rarer and denser are comparative. On a comparative basis, we are marking as rarer medium or denser medium. So this refractive index is also calculated with respect to some other. Okay, so this refractive index, suppose in this case I am calling sine of I upon sine of R as n, which is refractive index. So actually I will call it as n to 1. So meaning is that refractive index of material 2 with respect to material 1, right? Refractive index of material 1 2 with respect to material 1. This is the meaning of this. Understood? It means that the refractive, this sin I by sin r is nothing but the refractive index of the material in which the light is traveling to. Okay, and with respect to in which the light was traveling from. So that is why I told you that from case, traveling from case, I take it as 1. From traveling to case, I take it as 2. Okay, traveling to 2. That is how you can remember. So always we write refractive index like this. According to your textbook, I am using the same notation so that there won't be any confusion. Because what happens in different books, if you see, some different reference books, if you see, all have a different method of representing this refractive index. So it is better to follow what is mentioned in your textbook. So I am using the same convention which is used in your textbook. So n to 1 is considering, so as well as I am also considering that refractive index, we read this as refractive index of material 2 with respect to material 1. And what is material 2? Material 2 in which the ray of light is traveling to, like here. The ray of light was traveling to. Traveling to means in which the actually refraction is occurring. Traveling from is 1. So that is how we say the refractive index of material 2 with respect to material 1, that is n to 1. Okay, now this refractive index also have a definition. Let us see how this is being, how this can be understood. I am calling refractive index as n to 1. I told you that rarer medium means speed of light is more, okay, and denser medium is speed of light is less. And who is deciding this rarer and denser medium? Refractive index is an indicator which is telling you which is more rarer or which is more denser medium. It is a numerical value. Okay, when n is greater than 1, this n value greater than means it is a denser medium. Generally n is less than means it is a rarer medium. Now this 1 is a benchmark also, right? Let me draw this. Let me take the whole space of the board. So this I will write in the side, because this is also traveling from, I take it as the first medium, okay, and traveling to is nothing but 2, that is the second medium. Now what I am calling is that refractive index is the index which is marking your which material is rarer or denser. I say that n is greater than means it is a rarer denser medium, n is lesser than 1, it is a rarer medium. So denser, this I am calling as denser. So denser with respect to what? And this is rarer, okay. And refractive index of air is nearly, not exactly, nearly equal to 1, of which air is 1. It is actually the refractive index of air is what? Refractive index of air, refractive index of vacuum, let us say. Okay, if I am considering vacuum means there is no medium. In that case there will be no refraction. So what will be value of n? N is equals to 1, because we told you that sin I upon sin r is equals to n. Since if there is no refraction, what will happen? This is your normal, say this is your incident ray, and if it goes straight, so what will happen? These will be two. If it is a straight line, then this angle and this angle and this angle will be vertically opposite angle. Vertically opposite angles will be equal. So sin I will be equal to sin r. So these two will cancel and you will get as 1. So this is possible only in case of vacuum, in which the value of n is 1. And what happens if you take air? In air also, what happens with respect to vacuum? If you see air, there is a very slight amount of refraction occurring in air also, which is negligible. So n is what? It is exactly equal to 1.00. When you compare this with vacuum, that is what I was telling, that this 1 is for vacuum. Okay, 1 is for vacuum. When ray of light is traveling in vacuum, that means there is no refraction. So if n is equal to 1, it means it is vacuum. So if n is greater than 1, it means it is not vacuum. N greater than 1 means it is becoming, a medium is becoming more denser and denser and denser. So there will be more bending, more bending, more bending. So that is why it is denser with respect to this vacuum. Okay, and this means n is less than 1 means it is a rarer. It is rarer with respect to vacuum, we are saying. Okay, and what we do, since this air is also 1.003, the value of n is also coming as 1.003, we take the value of air is sometimes n is equal to 1 also, which is not exactly equal to 1, but you can see this, that in air also we consider sometimes that there is no refraction going on. So you can see that we can consider this refractive index with respect to some other material or some other, you can say, medium material. It is exactly we can say medium, which is more accurate word. So what happens is that denser and rarer are, and this nature is inversely proportional to the speed of light. So if I see this in term of a speed of light, what is happening? This refractive index of 2 with respect to 1 is what? Speed of light in 1, and this is speed of light in 2. Okay, this is another, this is what a numerical, you can say, formula for refractive index. So refractive index is getting dependent on speed of light. Okay, which in case I was telling you earlier that speed of light is more, it means it is rarer medium. If speed of light is less, it means it is denser medium. Okay, so this is what you can see, that if there is a denser medium, if a light is traveling from, suppose this is medium 1 and this is medium 2. Now if this is rarer and this is denser, meaning what? This value is what? Speed of in this is more. Okay, and the speed of this is in less. So numerator is greater and denominator is less. So it means that this value will be large. So this value will be large means refractive index is more. That means there is more bending. Okay. Also, if suppose this is denser, right? This is denser and this is rarer. Now let us consider the case of this. Okay, this is now your rarer medium and this is now your denser medium, right? So the speed of light, now the materials have changed. I will take this as 2 now. Okay, I will take this as second material. So second material, the speed of light will be more, and in this the speed of light will be less. So what will happen? Refractive index will be what? Refractive index will be what? The refractive index of material 2 with respect to material 1 will be what? Less. So what will happen? The refraction is the bending of light will be less. Okay, the bending of light will be there, but it will be less. So it will be going away from the norm. So that is the case, that it will bend lesser towards the normal. Okay, you can mark this as also. The refractive index is more with respect to the this first material. Then what is happening? In this case, the speed of light is more. Okay, because 2 is a rarer medium. So in this case, the refractive index will be what? The speed of light. This denominator will be more and the numerator will be what? Less. So speed of light will, what will be happening? what will be happening is that its refractive index becomes lesser. So that is why it will go away from the normal, right? This is how you can understand. So now let us write it more accurately, that speed of light, I will tell you this speed of light. Now speed of light, I will use the notation again. C I will use for speed of light, that will take less time. So speed of light means this will be what? C1 by C. Now suppose I am taking the first medium as air. Okay, first medium I am taking as air, right? Or if I am taking the first medium as air, so what will happen? The speed of light in air, or let us say for accuracy, we let us say that is now a vacuum, right? In vacuum, what will happen? The speed of light is c. I will call it as c, and it is traveling to some denser medium, so it will bend towards the normal. This is your medium 2, medium 1 is vacuum. So in that, speed of light is c, which is 3 into 10 to the power 8 meter per second. You know the speed of light which is in vacuum. Now this is now c upon c2. Understood? So if the material is 1, okay, then we don't use this one, we drop off this one. In case of a vacuum, we call this as N2, which is C by C2, or you can say the refractive index of this material. This was refractive index of 2 medium with respect to 1, right? Now this is absolute refractive index. Now this has what is become? Now this is absolute refractive index. What is absolute refractive? Absolutely with respect to this material, if you are saying, if you are taken as the first material as vacuum and second material as this particular material, this can be any glass, water, whatever. Now this is given by speed of light upon speed in material. So you can say that refractive index of, if I take this m, then this is what? Speed of light. So speed of light, we generally call it as speed of light in vacuum, which is c. I'm just rewriting this in a more standardized form. So C2 is what? Speed in material, speed in this m material. Okay, so this is nothing but your absolute refractive index. Now I am telling that glass is a refractive index of, I tell that glass, and in this case, if I using glass, I will write glass. So n glass means speed of light in vacuum c upon speed of light in glass. So this is the meaning. Okay, so this value comes out around to be 1.5, which is the refractive index for glass. I will use in subscript small. So these values you don't need to remember, it will be specified in the question. The only formulas which you need to remember, so you need to remember only that the light bends towards the normal when it travels from optically rarer medium to denser medium, and the reverse happens in denser to rarer medium. And this formula you must know. Okay, n to 1, this is refractive index of material 2 with respect to material 1, and you always draw the diagram like this. 2 means traveling form, so this will be your case, right? And this is nothing but, I told you that it is nothing but C1 upon C2. This is how refractive index is asked. And if I ask n2, which is nothing but, you just remove the 1 sign, it is now C by C2. Now 1 is what? For vacuum, or sometimes what happens, this is taken as air also, because the reason I told you, vacuum or air, you can consider both. Sometimes happens like that, because there is not much refraction in case of air. If this was air, then also sometimes this is considered with respect to air also. C1 or N1 is nothing but the refractive index of air, that we take as 1. N1, that we take as, if you take the, now let us find the refractive index of air. So what it will be? Refractive index of air will be what? I told you just the formula, Nm is equal to speed of light upon speed of light in material. So what is the speed of light? It is c. What is the speed of light in material? That is means what is the speed of light in air? It is nothing but c only. That is why that is somewhat lesser than c, very less than c. Okay, this will be see here, which is very 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 small difference, very small difference from C. So that is why this value comes around to be 1.003, which we take as 1. Okay, so that is the case. So you need to remember these formulas, and you are taking the refractive indexes. So this is the case of a refraction, that is a bending of light. So these points you must know clearly. Now, like mirrors, we are having lenses, okay, in which the refraction of light happens. So these lenses are somewhat whatever lens you are using in the cameras, right? So that is what the lenses which we are wearing in, say, specs, okay, your glasses, your eyeglasses, or whatever spectacles you call. So that are using nothing but lenses. So in that case also refraction is going on, bending of light is going on. So what is a lens? Lens we will learn about spherical lens. What we will learn, just like we have learned about spherical mirrors, we will see spherical lenses, and these are also of the same two types that were in the mirror. One is convex lens and other is concave lens. So concave lens and convex lens, how they are made? They are made from two spherical surfaces. One is like this and suppose another is like this. Okay, so this is your first spherical surface, this is your second spherical surface. So out of these intersection of two, suppose with the combination of these two, we are considering this part, okay, which is thick at the middle and thin at the edges. So this part if I draw, right, and this is your, so this is nothing but your convex lens, right? This is your convex lens. It is made of two spherical surfaces, right? And if I am taking a surface like this, let us say this is your first surface, right? And this is your second surface, right? Quite a big bigger. Okay, let us see. So this part, okay, this part, one from this spherical surface, another from this spherical surface, and we have a glass in between. One curvature is cut out from this, one curvature is cut out from this, like this. So this is nothing but your concave lens. So this is thinner at the middle. So physical appearance is that thinner at the middle, and convex lens is what? Thicker at middle. And this is thin at edge. Thinner at edges. This is thicker at edges. So these are the different lenses, okay, convex lens and concave lens. So this is about the construction. So we will be drawing lenses like this. Suppose this is your convex lens, okay, this is your convex lens, and in this case also we will consider this middle point, okay, this is your the line of symmetry which divide these lens into two equal parts made of two spherical surfaces. And in this case also we will be having a this point, center point, through this a ray will be passing, which will be calling as, this is now again your principal axis, just like mirror, okay. And this point which is at the center of this lens, we call this as, mark this by O, we mark this as O, and we call this as optical center. This is your optical center. And unlike mirrors, we have these two focuses point, and also these 2 point 2f2. So this is your f, this is your, because this lens is what? Identical from both the sides. This lens is identical from both the sides. So that is why we are having f1 and f2 here. Okay. And in concave mirror, in concave lens, sorry, we have like this. This is your concave lens. So this will be your principal axis. And this is again your optical center. So in this also we will be drawing ray diagrams, right? And this is your optical center, and again this is f1, again this is f2, 2f1, 2f2, which is nothing but your C mark. You can call it as C1, C2. So that is the point. Again, this is your focal length. This is your, okay. So this is also the same thing we follow. The aperture is very, the aperture is this size. This aperture means this curvature part is very less. Out of this sphere, if you are considering this, sphere, right? In this case, we are taking very small part of this sphere. Let us say like this, the small part. That is the meaning. Okay. So in this case also, what will be happening? Suppose now you need to understand one thing which is asked again and again in the some of the yes, in NTSC or in some advanced examinations or Olympiad, or maybe sometimes in your boards also, CBSE exams also. Suppose this is your lens. This is a convex lens, right? This is a convex lens. Okay. And what will happen? This is also a convex lens. Okay. So we will be drawing ray diagrams in the next class, right? So one thing you need to understand, this is also a convex lens, and this is also a convex lens. But what is the difference between these two? This lens is more thicker, right? More thicker, and this is what? Thinner. So what will be the, can you till now whatever we have studied, can you comment on what will be the kind of, obviously in case of lens, unlike mirror, what will happen? From one side the rays will be coming. We will be drawing ray diagrams. This is also, we will be drawing ray diagrams in the next class. But you need to understand that the rays are coming from this side, and in the lens case we always observe from the opposite side. Okay, that is where we will be observing. Okay, one side is the incident side and the other side is the observation side generally. Okay, in mirror we are observing on the same side, but our lens is what? This is a transparent. Okay, so in this case we are making incident light on one side of lens and we are observing on the other side. So can you tell about what will happen to the ray of light theoretically if it travels in these lenses, two different kinds of lenses? What you can understand is that here now in lens what happens? Refraction is taking place. So what will happen? This is air. Again this lens is made up of glass. Okay, again this is your air, and again here it is air, this is glass, and this is air again here. So the ray of light will be traveling from air, traveling into glass, get refracted, again traveling into air, again gets refracted, and it will be traveling. So that is the kind of path it will be, that is the track it will be following. So what you can say here, there is more, the lens is more thicker, means that the light will stay in medium 2, that is the light will stay in more denser material for a longer time. So that means in this case there will be more refraction. Okay, and in this case the light will be traveling lesser in this glass medium. Okay, in this case the ray of light is traveling less in this denser medium, in this glass medium. What will happen? It will bend little than this first case. So there will be less bending or less refraction. So please keep these two things in mind, because now in the next class I will be discussing about the focus points of these convex lenses and concave lenses. Okay, so lens is what? It is made up of two spherical surfaces and it is made of glass. It is a transparent. Okay, so light is incident on one side and it emerges from other side. We observe it in other side. This lens is similar to what we are wearing, such as this spectacle. It is nothing with one of these types of lenses. Okay, so please keep this point in mind, that is convex lens and concave lens, that in thicker lens there is more amount of refraction going on. So that will govern how this how quickly these rays will be meeting at the focus point. Okay, based on this thicker and thinner lens, the quality of refraction will be changed. So that is what is about today's class. So let us summarize what we have learned till today, because today there are too many things you should keep in mind. First of all, you must I will draw the diagrams so that it can be remembered more. You can say picture memory is more, you can see more, you can say what more, it retains in your mind for a longer time. So if I am taking this as the normal, right, this was medium 2, this was medium 1, incident ray is traveling at an angle. Then if 2 is denser, 2 is denser than 1, it will bend towards the normal. And in this case, if the case is just opposite, if it is a, this one is more, 2 is rarer, then what will happen? This incident ray, speed of light will be increased in the rarer medium, it will be bending away from the. So this you must remember. You must remember what are the laws of refraction. First one is very simple, that is that it should be in the same plane, refracted, incident and normal ray. Second is what? Sin I upon sin R, and this is your angle of incidence, this is your angle of refraction, this is your angle of incidence. Okay, and in this case what is the angle of refraction? This angle of refraction with the respect to normal you are measuring. Sin I by sin R is what? N. This is your Snell's law. Okay, and what we tell is that n to 1 means refractive index, because I am summarizing, I am writing this again, refractive index of material 2 with respect to material 1, and we write it as, in this case I will write sin I by sin R. Suppose I am considering this case, so I will write this refractive indexes n to 1, where refractive index of material 2 with respect to 1, you can easily see that this ray of light is traveling from 1 and traveling to 2. This is important, and this is also speed of light. This will be used in some numerical in 1, and this is what? Speed of light in. Okay, so if I take air or vacuum as the medium, as the first medium, air or vacuum, if I take air or vacuum as this medium one, suppose this is air or vacuum. Okay, I am not considering the slight difference between the air and vacuum. So if I am taking this as 1, what will happen? You will replace this 1 by nothing, you will just write n2. You will write speed of light in 1. So 1 is what? Now air or vacuum. So speed of light in air is, or vacuum, we mark it as C and C. So this is what your absolute refractive index. So these formulas, this formula and this concept, numericals can be asked from this concept. Okay, be prepared. So we can solve some of the numericals when we will complete this refraction part. We will be solving numericals. We will be using this formulas, right? And I have told you the general introduction of the spherical lenses, that is convex lens and concave lens. So that is also, you remember the construction of convex and concave lens. And we have also seen some practical examples of refraction, that why there is an apparent shift in an object placed at the bottom of a surface which is filled, bottom of a container which is filled with water. So what happens in that case? You observe somewhere from upside, then in that case that object appears to be shifted upwards, not at that exact location. So that is because of refraction also. So that is what we have learned in today's class. So this is nothing but bending of light, and we will continue with our discussion by seeing the focus point. We will be more elaborating on the spherical lenses, and ultimately we will be seeing the ray diagrams of these spherical lenses. Okay, just like we have considered the ray diagrams in the mirror case, there will also be construction, there will also be nature size nature, size and position of image. Similar analysis will be done on convex and concave lenses also. Then after that, all this we will be seeing the numericals related to this lens part. So thank you for today's class. Thank you. And now we will be seeing that